Now in part 2 we have to deal with the ACS 712, which is the Hall effect sensor for current measurement. So we have to first, I want to show you the simulation of this. This is the simulation, this is the ADC value, this is the voltage, this is the current value. So now we have to this is the diagram. This is the simulation, that how it is running. This is the LCD connected with the Arduino ACS 712. This is ACS is a 30 ampere. It can measure up to -30 to +30 ampere. So we have to take the snapshot of this diagram. This is the circuit diagram of the simulation. Now we have to run it. So we have to start it by blank. Okay, first I have to save this project for you people. Lab10 ACS Lab10, and I want to save it on and we have to so it is saved. Now we have to start new project. For new project we have to start with the pick part of Arduino. This is Arduino part. We have to select it. Now we have to select the potentiometer. This is the potentiometer. Now we have to select the LCD. G044L. This is the LCD, and now we have to select the ACS 712. We have to use the 30 ampere. Now we have to use the battery. And we have to use the ground pin. Now we have to use the ground here, here, and we have to power supply. Okay. Now we have to give connection. So we have to connect for this data not D not pin. We have to connect D7, D6 and D5 and D4 pin number 14 with okay. First we have to okay. Sorry. Okay, we have to connect uh, connect 14 with 13. Sorry. Fourteen with 13. 13 with 12. 12 with the 11 number pin, and 11 with 10, and 8 and 9 are connected with the enable pin and RS pin. That is with enable, so we have to for purpose of we have to make it with some rule. The routing must be with some rule. Okay, now we have to short RW pin with VSS pin, and then we have to ground it. We have to ground it. Okay. RW with VSS, and we have to connect move this here, and voltage across double pin will be connected to the center pin of the potentiometer. And VDD pin is connected to the and we have to connect the other pin with the okay, we have to little bit okay, it is correct. Okay, now we have to use this one pin, this power as a 5 volt. Now we have to connect with, now we have to move here, and connect with VCC with positive terminal of the battery, and ground with the ground with negative terminal of the battery. And we have to ground with the negative terminal. Now we have to connect now we have to connect the VI out pin with pin number 7. And use the lamp. We have to rotate it. Now we have to connect this. And now we need DC ammeter. We have to rotate it. And you have to connect in cloud. Now we have to use here 5 volt. And this is our 10 volt supply. Now we have to upload a code to this Arduino, So for this we have a code. This is the code. Okay, wait. Here it is, the code. In this code we have to discuss it. We have to discuss this code. This code. We have pin number 8, 9, 10, 11 and 12. Initialize the library with a number of interface pin 13, 12, 11, 10, 9 and 8. 10, 9 and 8 LCD pin are connected with these pin of the Arduino, like same as the code. We have to with the code. We have to look into it. 8, 9, 10, 11, 12 is connected with the LCD, and its sensitivity is sensitivity mean the minimum value that it calculated. Okay, so the initial sensitivity is 1800 and the offset value is 2.5. It is 2.5 volt. It is 2.5 volt to 500 millivolt, which is equal to 2.5 volt, because when there is no current passing through, its offset value is 2.5 volt, and its sensitivity is for 30 ampere it is 66, and for 20 ampere it is use 100 for 20 ampere and 66 for 30 ampere. Okay, so here is the serial begin, it is the baud rate, and when it begin, so the message to LCD, set cursor on row 1 and column 1 on the LCD, and set cursor for 4 comma 2. It is on 4 comma 2 you have to set the cursor, and .com is printed here, and time delay of time 3 second delay, and LCD will be clear after 3 seconds, will be clear and display on the gain, and set cursor print read value, print on the, and cursor DC current value on set cursor 5 comma 2, and print ACS 712. So first you have to set the cursor 1 comma 1, 1 comma 0. On 1 comma 0 you have to set the cursor, and first you have to set the cursor 1 comma 1, and you have to print the microcontroller lab, and then 4 comma 2 you have to print the .com, and on 1 comma 0 you have to print the reading value form, and from 1 comma 1 you have to print the value DC current sensor, and and on 5 comma 2 you have to print value ACS, which is a sensor, and after it will be printed after 200 delay, mean it is 2 second. This is the analog reading on ADC value. This is the ADC value which Arduino use by using analog channel. This ADC value is divided by 1024, where 1024 mean it is 2 power 10, and 5000 mean 5 volt, and ADC value is divided by 2 power 10, and it is multiplied into 5, and this value is subtracted from offset voltage. Okay, so raw data print on the screen. It will set cursor, okay, print voltage, and set cursor and measure. Okay, this is the code. We have to copy this code, Control C, and we have to paste it here. Okay, we have to paste it, but there is no in Proteus we have no hardware Arduino connected, so we click on the preferences, and by default it is checked, but we have to uncheck it. Okay, only check the compilation, click OK and verify it. Now after verification you get this link. Okay, this is the link for your hex file, so you have to use this hex file. So click on this Arduino and use this hex file. This hex file is on user, this is the user, then user app data, this is app data, local temp, file, and in temp file it is belt 60. Here is a hex file, you have to click on it and it is open. So okay, now you have to run this code. There is no supply specified for net 5 volt. This is the error, and we have to remove this error by using battery. You have to connect it, and you have to connect this pin as a ground, and use it as a 5 volt. It's okay. Now you have to run it. Maybe a program is not defined. Real-time simulation failed to start. Okay, we have not defined it, so we have to first give path, the path which we left here, here, app data, local, app data, local, temp, build. We have to give a path. Okay, now it is path is given, so we have to now run it. So you have to look into it. Okay, you have to stop it now and move this okay, now we have to run it again. Okay, this is fault due to my system, so we have to stop it. Okay, we have to stop it, and we have to, and then we have to again, this is due to the CPU load. Okay, okay, we have to stop it. Now we have to due to CPU load, but we have to use ground, because it is not given to this point. Now we have to rerun it. Okay, this is the code, and we have to now discuss it again. The code, we have to discuss the again code. This is the reading value row 1, row 2. This is the, okay, now it is 13.4, and what is the value of, and 13.48 ampere. So we have to we have to zoom out, and we have to zoom in. We have to find this value. It is 4.47 ampere. Okay, we have to stop it, and we have to rotate this. Okay, now we have to run it. It is 0.41 ampere here in series, and this there is the value of, here is the value of. Now it start again, and ACS sensor is a DC current sensor. It will give the value of 13.48 ampere. So this is the procedure to how to simulate it.